Hi there, my name is Dimitri, and I'm very happy to welcome you to this course on numerical methods. Now, before we get our hands dirty on actually applying numerical methods, I want to talk a little bit about who made the course and what the course contains, that sort of thing. So, first of all, the authors, my name is Dimitri, as I mentioned. I'm a quantitative analyst and a programmer. I do stuff related to applications of technology in automated trading and quantitative finance, that sort of thing. But for this course, I had some help, so all the narration, all the actual content was made by me. However, all the content was prepared by Zini, who has been very helpful in getting the actual content for this course. So it is entirely a joint effort, this one. Now, this course is designed for mathematicians, computer scientists, engineers, and basically anyone who needs a numerical solution to some problem. It really doesn't matter what kind of field you work in. So you work in civil engineering, for example, or you are an electrician, whatever the case, you can still apply some of the numerical methods presented here to solve particular problems. So what kind of problems are we talking about? Well, for example, if you look at the integral of log of x between some two bounds, then sure, you can go into MATLAB and we know the analytic solution for an integral of a log. We know what it is. But let's imagine you're stuck with a calculator, or let's imagine you want the calculation done very quickly. Well, in this case, what you can do is you can just plug in a few values. So you can take the lower, the upper bound, and the middle point. You can multiply it by some magic value. And as a result, you'll end up with something that looks like this. So you have a result to 6 decimal places. Now, if we were to actually sneak a peek at the actual value in MATLAB, then you'll see that the value given by MATLAB and the value that we got is only different at the 6th decimal place. But the advantage of our approach in applying numerical methods is that this is something you can do on a calculator which has the log function, whereas for the absolutely precise result, we had to use a computer algebra system. Another example is an integral which doesn't have an analytic solution. So for example, an integral of 1 over the square root of 1 plus x squared is not something you can describe in analytic format. So numerical methods are the only thing that you've actually got to sort of find the actual value. And similarly for this equation, x equals e to the minus x, once again, this isn't something that we can simply solve analytically, but applying numerical methods, we can find out what the result is, at least to some degree of precision. And final example, let's suppose you're solving an equation ax equals b, where A is some large matrix. Let's say you have a 100 by 100 matrix. Now, computers are capable of solving such equations. The only problem is that the amount of calculations that need to be done in order to solve something like this is actually detrimental to the final result, because in doing lots of calculations you lose a lot of precision, and as a result you may end up with an answer which is really far away from what the actual answer happens to be. And once again, this is where numerical methods are applied to give us better answers and to give us those answers faster. So let's talk about what's actually in this course. First of all, we're going to talk about the machine representation of numbers. Let's not kid ourselves. Everything that we do is done on the computer, and computers have limited capacity for storing numbers and for operating on numbers. So we need to be aware of what the computer actually does to a number once we type it in, because remember that if you type in something like 0.1, the computer doesn't really store 0.1. Indeed, it cannot store 0.1. So that's something that you need to be aware first of all. Then we're going to talk about a couple of kind of important theorems and findings in numerical methods. Just a couple of concepts that we need to keep in mind and apply later on. So these are things like Bolzano's theorem, for example, very common stuff that we're going to be using throughout the course. And then we jump into the meat of the matter. So we're going to talk about one-point iterative methods, two-point iterative methods. We're going to talk about interpolation and curve fitting, and then we'll talk about numerical methods applied to differentiation and integration, the so-called quadrature. So this is what you're going to see in this course. So let's jump in.